Hello students, welcome back to Top Notch Online TV, the Ocean of Knowledge. You are with me, teacher Thaddeus Mbaluka, the Ocean of Chemistry, and your certified chemistry mentor. In our today's lesson, we'll be looking at preparation of salts. And this topic, it cut across both Form 2, Form 3, and Form 4 work. So we'll be able to synchronize the knowledge you acquired in Form 2, in Form 3, and Form 4 to be able to answer questions on this particular topic. So work with me as I try to give you the tricks in answering questions on salts. So let's start at point number 1. For you to answer any questions on salts, you need to have the solubility of salts in your fingertips, if not in your nerves. I have tried to summarize the rules of solubility into 4 main rules from 7. So first of all, we have all salts of sodium, potassium, and ammonium are soluble. All salts of sodium, potassium, and ammonium are soluble. So when you pick any sort of sodium, any sort of potassium, or any ammonium salt, it will be automatically soluble in water. Or nitrates, acetates, hypochlorites, chlorates, hydrogen carbonates, and perchlorates are soluble. But the most important that you need to know is for your syllabus, you don't have to cram all these ones. So the only ones you need to know is all nitrates and all hydrogen carbonate. Those are the only ones that you'll be taught. Nobody will tell you to prepare perchlorates. Nobody will tell you to prepare acetates, but you just need to know the solubility of nitrate and hydrogen carbonate. All of them are soluble. First of all, let me tell you, is that the only hydrogen carbonate that exists in solid state are those of sodium, potassium, and ammonium. Then we have magnesium hydrogen carbonate and calcium hydrogen carbonate, though that only exists in solution form. So we don't have solid magnesium hydrogen carbonate, and all the other hydrogen carbonates do not exist. We don't have a zinc hydrogen carbonate. All sulfates are soluble except those of lead, barium, and calcium. But remember, calcium sulfate is sparingly soluble. The mnemonic to remember the insoluble sulfate is sulebaka. Sulebaka for Su, that is sulfate. All sulfates are soluble except those of those of lead, barium, and calcium. Sulebaka. All chlorides are soluble except those of lead and silver, but lead chloride is soluble in hot water. The mnemonic is glassy. All chlorides are soluble except those of lead and silver. Remember that all metal oxides, metal hydroxides, and carbonates are insoluble except those of sodium, potassium, and ammonium. Remember, ammonium is also any ammonium, hydroxide ammonium, carbonate will also be soluble. But remember, we don't have ammonium oxide. That's very much important for you to be able to understand. So once you have understood the solubility rules, then now we can now talk about preparation of salt. Remember, you cannot talk about preparation of salt when you don't know whether it is soluble or insoluble. Remember, somebody will also tell you to be able to prepare an hydroxide. So you need to know also the solubility of hydroxide. So this one is simply showing you the solubility of salt, the advanced, that the soluble sulfates and chloride. But remember, we are only interested with the chloride of silver and chloride of lead. For sulfates, we are interested with that one of lead, barium, and calcium solubility. Then all the other sulfates are soluble. We continue. The objective of this lesson should be able to know the learner should be able to describe how to prepare soluble salts, how to prepare insoluble salts, and how to prepare possibly the separation of mixtures. So how to prepare soluble salt, how to prepare insoluble salts, and then we talk about the separation of salts. So let's look at that's still the same. So look at preparation of soluble salts. I want to show you that a simple methodology to be able to prepare a soluble salt. You don't have to cram so many procedures. The procedure is the same. One is that when you're preparing a soluble salt, you can use a metal oxide, metal hydroxide, metal carbonate, metal hydrogen carbonate plus an acid. So we are saying when you're preparing a soluble salt, and the starter reagent is a metal oxide, metal hydroxide, metal carbonate, or metal hydrogen carbonate plus an acid. I want to show you a simple method that you can use for all these preparations. And how do you go about that? So when you are preparing a soluble salt, and the starter reagent is a metal oxide, metal hydroxide, metal carbonate, or hydrogen carbonate, you start by add excess metal oxide, metal hydroxide, metal carbonate, or metal hydrogen carbonate to a dilute acid. That is step number one. It doesn't matter. So you don't have to cram how to prepare zinc sulfate starting with zinc sulfate starting with zinc oxide, zinc sulfate starting with zinc carbonate. The methodology is the same. That you add excess metal oxide, metal hydroxide, or metal carbonate, or metal hydrogen carbonate to dilute acid. Why are you adding excess metal? Why are you adding excess solid? To measure that all the acid has reacted. Then after that, you filter. Step number 2, marking point. After filtering, you're going to heat the filtrate to saturation, then you cool to crystallize. Of course, after crystallization, the marking point normally stops there, but you can also add, after you crystallize, you filter, then you dry the crystals between filter paper, because sometimes the examiner can tell you how to obtain dry crystals. Remember, after you've heat the filtrate to saturation, then you cool, the crystals are formed. To separate the crystals from the mother liquor, you filter, then you dry the crystals between filter paper. So if the examiner goes ahead and asks you to obtain dry crystals after you cool to crystallize, you need to filter again to separate the crystals with the mother liquor. Then you dry the crystals between filter papers. Are you finding this one very simple? That's exactly what you need. Add excess metal oxide, metal hydroxide, or metal carbonate to dilute acid. Filter. Heat the filtrate to saturation, cool to crystallize. I'm now giving you the examination content. This is the examination content, not what is in the books. Remember, I always tell students that wherever you are preparing for the exam, you focus on what is tested, how it is tested, and what are the expectations of the examiner. So now, let's look at a sample question Let's look at a sample question. So before you go to a sample question, there are points to note that, and I've already explained that. Excess metal, metal oxide, metal hydroxide, or metal carbonate, or hydrogen carbonate is to measure that all the acid has reacted. To filter to remove unreacted solid. You filter to remove unreacted solid. You filter to obtain to you filter to remove the unreacted solid. So we are saying the points to note is excess metal, metal oxide, metal hydroxide, metal carbonate, or hydrogen carbonate is to measure that all the acid has reacted. You filter to remove unreacted solid. If it is unreacted metal, if it is reacted metal oxide, or unreacted metal hydroxide. Then this is the illustrated method of separating this. So when now you have now added the when you have now added the excess solid, then you have filtered now the salt solution. Now you put in an evaporating dish, then you heat it to evaporate the excess, heating to evaporate the excess water, or rather to remove the water. Then now it becomes a saturated solution. Then the saturated solution, now you cool it to crystallize, and then you can be able to obtain the crystals. You can have the crystalline salt as shown in this diagram. So when you filter, you're going to have the crystals, and you can have now the mother liquor. Sample questions with answers. Number 1, starting with the magnesium metal, describe how you can prepare a solid sample of magnesium chloride. Here the starter reagent is a metal. You want magnesium chloride. So the acid thing that is being used there is hydrochloric acid. So how do you answer that question? Add excess magnesium metal to dilute hydrochloric acid. Filter. Heat the filtrate to saturation. Cool to crystallize. Add excess magnesium metal to dilute hydrochloric acid. Filter. Heat the filtrate to saturation. Cool to crystallize. And if the examiner requires you to have dry crystals, after you cool to crystallize, you filter. Then you dry the crystals between filter papers. Add excess magnesium metal to dilute hydrochloric acid. Filter. Heat the filtrate to saturation. Cool to crystallize. And if you want to obtain dry crystals, as I've said, we are going to filter, then we'll dry the crystals between filter paper. So whatever you're told is that now, the examiner will require you to, we are talking about the excess magnesium, very key, then to dilute hydrochloric acid, that is the first marking point. Then you filter, you heat the filtrate to saturation, then you cool to crystallize. Those are the main marking points. Another question, let's use something else apart from now here we want to prepare zinc oxide. We want to prepare zinc sulfate, and the starter reagent is not a metal. It is now zinc sulfate. So starting with zinc oxide, describe how you can prepare a solid sample of zinc sulfate. So you start by add excess zinc oxide to dilute sulfuric acid. Filter. Heat the filtrate to saturation. Cool to crystallize. As simple as that. Add excess zinc oxide to, and remember it must be dilute sulfuric. Filter. Then it's not important to tell the examiner the reason for filtering. So the examiner knows. There is no marking point for telling us why we filter. So you filter, and to obtain zinc, the unreacted zinc and zinc sulfate as a filtrate. Then you heat the filtrate to saturation, allow it to cool for crystals to form. Then again you filter again. Then if you filter again, this now you are filtering and then you dry the crystals between the filter papers. But this statement is not very much necessary. This one may not be very much necessary for that. Another question is, starting with zinc carbonate, describe how you can prepare a solid sample of zinc sulfate. So the same is just like in question 2. The only difference here is that we are going to add excess zinc carbonate to dilute sulfuric acid, then you filter, then you heat the filtrate to saturation, then you allow it to cool for crystals to form. Add excess zinc carbonate to dilute sulfuric acid, filter, remove unreacted zinc carbonate, and then zinc sulfate as filtrate. You remove the unreacted zinc carbonate as residue, and then zinc sulfate as a filtrate. Heat the filtrate to saturation and allow it to cool for crystals to form. Then, as I said, if you want the crystals to be obtained in dry state, you have to filter. Then the importance of filtering here is to separate the mother liquor from the crystals. Then if you want the crystals to be dry, then you dry them between filter papers. Then now these are questions that is a little bit difficult, and many students will get confused. These are questions that many students will not get. Starting with copper metal, describe how you can prepare a solid sample of copper 2 chloride. This now question deviates from the other in the fact that you cannot add excess copper metal to dilute hydrochloric acid, because copper is below hydrogen in the reactivity series, and therefore copper will not react with dilute hydrochloric acid. Therefore, the first step here is you burn copper in air to form copper 2 oxide. Then now you add excess copper 2 oxide to dilute hydrochloric acid, filter, heat the filtrate to saturation, allow it to cool for crystals to form. So heat copper in air to form copper 2 oxide, add excess copper oxide to dilute hydrochloric acid to form copper 2 chloride, filter to remove unreacted copper oxide and copper 2 chloride as the filtrate, heat the filtrate to saturation, allow it to cool for crystals to form. Then you filter in order to separate the mother liquor from the crystals. So common mistakes students make is that they start by reacting copper metal with dilute acids. And copper may belong hydrogen in the reactivity series, does not react with dilute acids, and therefore the candidates will lose all the marks. Such candidates are called non-starters because the first statement is wrong. Remember, there is also another question that you can be told to answer, or rather to answer, like how you can prepare sodium chloride by direct synthesis. How can you prepare sodium chloride by direct synthesis? Here you cut a small piece of sodium metal, you put it in a deflagrating spoon, then you heat it briefly. Cut a small piece of sodium metal, you put it in a deflagrating spoon, then you heat it briefly. Then, on heating it briefly, you lower it into a gauge full of chlorine gas. It will react, forming sodium chloride. Cut a small piece of sodium metal, put it in a deflagrating spoon, lower it into you heat it briefly, then you lower it into a gauge containing chlorine gas. It will react, forming sodium chloride. You can also be told how to prepare magnesium chloride by direct synthesis, or any other metal chloride. So what you need to do is you can pass chlorine gas through a heated metal in a combustion tube. it will react, forming the corresponding metal chloride. And that's the end of the first session on how to prepare soluble salt. So in our next lesson, we'll be dealing with preparation of insoluble salt. So keep it here for the next session of preparation of insoluble salt. Until next time, continue following the Top Notch Channel TV. And if you have your young brothers and sisters, let them also follow the Top Notch Kids channel, whereby we are providing very relevant content for the kids.